Good morning. I hope everyone's staying happy and healthy. This presentation is designed for Communications 4494 as a part of the Technology Education Diploma here at BCIT. Today I'll be demonstrating how to build a metal rose in the form of a PowerPoint as well as a video demonstration. So let's get started. In this video, we'll be breaking down and discussing what materials, tools, processes, and even some techniques that we can use to construct our metal rose. We'll also be discussing the suitability of this project in a technology education setting and how this project can evolve. I think the lady in figure 4 is not pleased because she actually wants a metal rose, so let's see what we can do. Okay, step 1, picking your material. This project's a great opportunity to go through your scrap bins and see what you have. And that's exactly what I did. I went through the scrap bins at BCIT and I found a little piece of 18 gauge sheet metal, and I decided that would be perfect. It might be an idea to use a 20 gauge or thinner for younger students if you're doing this in the classroom, just because then you can take away the option for using heat depending on the capability of your class or the person doing it. So thinner gauge, you can bend it all by hand, and it just makes the project go quicker and it takes that element away. So step 2, layout. Once you've found your piece that you're going to work with, in my case that 18 gauge sheet metal, you want to lay out some layout die, or if you have a big Sharpie, that'll also work. And you want to get your compass and just draw 5 circles on. Doesn't matter what size, but depending on how big you want your rose, the size of the petals will vary. And with each one, you want to start with your biggest and then increase down. You can go anywhere from 1/4 of an inch to 1/8. It really depends on you. And if you're in a classroom, you could assign that. But before you go in with the scribe, you want to make sure you center punch. These center punch holes or marks will come in handy later on down the line of processes. So you want to make sure that's your first step once you get the layout die on, is you center punch, then scribe, and then once you do that, you're done step 2 and you can move on to step 3. So step 3 is when you really feel the ball getting in motion. You're going to cut out your pieces, and that's the first step that you kind of feel like you've achieved something. So you're going to cut your pieces out, you've scribed them, and the mark should be visible because we use some layout die or that Sharpie. So depending on what thickness of metal you used will depend on what tool you use to cut your piece. So I used 18 gauge and I tried to use tin snips. It was a little tough, so I jumped onto the Beverly shear, and you'll see that. But regardless of what you cut it with, you need to be careful because there will be sharp edges, you will have burrs, and if you're not careful, you will cut yourself. So the idea of using some gloves might be handy, or a good idea, but they could be bulky in the same sense and open some other hazards. So with discretion, you decide what best fits you. So here we have some different tools that you could use to cut, like I said, depending on the thickness of gauge you decided to use. So in figure 8, you have those tin snips. Like I said, I was using those, but it was a bit tough, and I like to work smarter, not harder, so I jumped on the Beverly shear, and that did the trick really quick, cut like a hot knife through butter. And if you're going even thicker gauge than what I was using, it might be an idea, it's a quick way. You can use a angle grinder with a cutting disc, but it can be a bit sketchy, so I'd suggest Beverly shears your best bet, but if Beverly shears are having a hard time, an angle grinder will work. But proper PPE that we won't discuss in this video should be taken if you're using that. So like I said in step 3, you have burrs and your piece will be sharp and dangerous. So you want to take those off. So here we come to a safety check. Make sure you take those off now so you don't forget about it and come back to it and cut yourself, or you show a teacher and the teacher picks it up and cuts himself. So we'll go with the flat file. This file will work for any thickness of metal. Thicker stuff you might have to work a little harder, but it'll get the job done. And you want to be safe when you're working. In this moment in time, we pass the safety check, we file down those sharp edges, and we have our pieces cut out and ready to be center punched. So remember I said you want the center punch marks? This is why. You're going to take it over to the hole punch, and the hole punch has kind of a little sharp die that'll fit perfect in those little marks and make punching really easy. So here I used a 1/8 die and punch my hole. But this can depend on what you're using for rod. So I found some 1/8 rod that would work perfect. And so if you find something bigger, just punch a little bigger. You do want the center of your diameter of your hole a little bit bigger than your rod. It's not crucial. You can always hammer down your piece onto the rod, but a nice fit's good. Also, you don't want it too big because you will be tacking these onto the rod, and you could get burn holes and it could melt or blow out if your gap's too big. So keep in the range of realistic. Step 5, so it's now time to shape your pieces. This is one of my favorite parts because this is when you start giving the rose some life and personality. And it doesn't have to be perfect because nothing in nature is perfect. And actually it's the imperfections that make these roses beautiful. So we cut out 5 circles. 4 of those circles, the 4 largest, we're going to be using for our petals. And you want to cutting down, leaving about an 1/8 gap of material between your hole in the center and the cut edge. You want to cut about anywhere from 4 to 5 petals. You could even do 3 if you wanted to get crazy, but between 4 and 5 is good. It's a nice workable number. And then so the smallest petal, or the smallest circle rather, you're going to be cutting into kind of a star, and this makes the rose hip of the rose. So that'll be on the bottom, and then you'll layer the biggest, second biggest, third biggest, smallest, and then that'll make up your rose. So just cutting those to how you like, how many petals. Once again, you probably use the Beverly shear, or if you're using thinner stuff, tin snips. Just a side note, as you're cutting, you want to keep your scraps. This is important because you can use them, and why throw something away you can use? So you want to keep bigger scraps so you can make some leaves out of it, and this will just enhance the beauty of your rose and make it look more real. And here in figure 15 to 17, you can kind of see how the piece of scrap evolved into some leaves. And you can use as many leaves as you want, as much scrap as you have, leaf that rose up. Now that you have everything cut out and ready to go, you have your rod that fits nicely, you're going to want to jump in the welding booth. But before you do that, you want to take the PPE and the proper precautions to do so. So you want a welding helmet, about 13 shade setting on the welding helmet, some leather gloves, leather jacket, and some steel toe or closed toe boots. This is precautionary and standard equipment for welding and should be taken. So once you're all geared up, then now you can go set up your welder and get welding. So step 6, bonding. In this case, we're bonding with weld, or a welder, MIG welding. You can really use anything depending on what material you're using. If you're using cardboard, you can use hot glue. If you're using copper, you might get away with some braze, or solder rather. And if thin gauge metal, you can use braze. I actually tried using braze with the 18 gauge, but because it was thick, I needed heat to melt it, bend it all up, and it would melt the braze away, so it just turned into a mess. So depending on what thickness of metal you're using will depending on your bonding agent. But we used a MIG welder during the creation of this rose, and we set the MIG welder at 4.5 volts and a wire feed at 55 inches per minute, and it worked very well with this material. In figure 20 to 22 here, you can see the process of welding. So you want to start with the little butt upside down, tack it up, and then you want to flip it over and start layering one at a time, layering your pieces of petal. So the biggest one, tack it, lay the other one, tack it, other one, tack it, and so on. And then you with your last weld, you'll want it nice, kind of flush. So you want to go and then just put a little bead there and make it nice and pretty. So you got your rose all welded up and you cooled it off so you don't burn anyone you're showing your beautiful work to. So now it's time to go to the demo and see you there. It's almost time to start with the demo, but first I thought I'd run you through the oxyacetylene we're going to use. But first we should talk about some PPE. So you're going to want some gloves, and you're going to want some shaded mask, or normally you have oxyacetylene, but I have my welding mask here. As long as it's around shade 4 or 5, you should be good, and this can go down to that. So that's what I'll be using. Now come to the tanks. Also, you're going to want a long sleeve to protect your arms. Okay. Now the tanks. So we have our acetylene here. You can tell it's acetylene because the red hose is going to it. It's a black tank though. Colors do vary because of course here, a little contradictory, we have our oxygen and it's a red tank. But you know it's oxygen because the green hose is going to it. So first things first, you approach your oxyacetylene, check the valves. It's going to be off. Hopefully the person that used it before you took the proper precautions to turn it off correctly. So what I like to do is I like to crack my acetylene open a bit so that valve's open, and then I open the tank. I just do a crack because in case of an emergency, you want to be able to access and turn it off quick. So I do it a crack open, or a little bit of a crack, maybe a half a turn or so. And then I see the PSI go up. I see how much is in the tank by this gauge here. This is the tank regulator and this is the hose regulator. I'll show you a little closer in a second. So I crack my acetylene and then I will adjust the PSI that's running through the hose to about 5 PSI with the regulator here. Once again, I'll show you. It's a bit of an awkward situation. And then you can hear a bit of a hissing coming out as you're adjusting the diaphragm in the regulator to make sure the certain amount of PSI is coming through. So 5 is a safe working PSI for acetylene. Anything higher, it starts getting to a little more of a danger zone. It's not dangerous, but acetylene is volatile at 15 PSI, which means it can ignite itself and explode. But we do have acetone in this tank. Acetone's heavy and it stays at the bottom and it neutralizes the acetylene a bit. So it's important to always have these stored upright so that the acetone doesn't come out. A lot of A words here. So the acetone doesn't come out and then the acetylene can get volatile. So it's nice to keep that mixed up and stored upright. So once you have your acetylene flowing through, you're going to turn it off on your torch. And then you're going to do a similar process with your oxygen here. So you're going to crack the oxygen on your hose here and then open it on your tank once again about a half turn, quarter turn. And then you should see the gauges light up, except the regulator gauge, because hopefully whoever turned it off backed this up all the way. And well, falls off. So that probably needs to be looked at. I am from the future, and you'll see that I ran out, and it might have been because these regulators are a bit old and janky, so I got to take a look at that. But let's assume that they're perfectly good. So you're gonna back it off. So the hose regulator will be blank because the person that used it before you bled the hoses. And then you should see in your tank regulator how much oxygen you have in your tanks. So you're going to adjust, you're gonna push in your valve or the regulator until you see about 20 PSI in your hose regulator. And then you'll hear the hissing come out. When you see about 20, you know that's good. So you can turn it off on here. And you know that your hoses have the correct PSI coming out, or feed rates. So and then when you first start it up, you're gonna want your gloves on and your helmet ready. I'm not actually gonna turn it on, so I'm not gonna deal with the helmet at the moment, but I do have my safety glasses, it's just precautionary. So you have your sparker. It's important when you turn it on that you turn on the acetylene first, and you'll hear your hissing. You're just gonna crack this, the regulator on your torch, or the valve on your torch, crack that open. Then with your sparker here, you're gonna spark, and a little bit should come out. You'll see fire. It might startle you in the beginning, but that's not an issue. You'll know it's good when you keep adding acetylene until your flame kind of looks like a dragon fire and the black smoke is gone. You'll see in the next scene or next video, watch the flame for that. I'll try to commentary it a little bit. So once that's good, you have your nice dragon fire coming out. It's looking nice. It's still attached to your torch. That's important. So now it's time to add your oxygen. So you're gonna crack your oxygen open and your torch is gonna and kind of come down. My charades aren't the best, but it's gonna kind of come down and start focusing. And then the cone will start meeting on the interior cone of your flame here. And when the two cones meet, that's called the neutral flame. And on this, because it's a number 4 head, it's going to be maybe about 1/4 of an inch long, maybe a little bit longer. But that's what you're gonna work with, and that's the flame you're gonna work with your rose. Like I said, I'm from the future, so the rose is all done. Wow, look what you're gonna make. You excited yet? So you're gonna go around and lightly work the rose, like you'll see in the videos, with a nice even heat. You don't wanna be too close to melt the metal you're working with, but you want to stay nice close so your metal stays cherry hot. So once you've worked it all, it's time to turn off your torch. So you still have the flame going. You turn off your oxygen first. You'll get that dragon fire again. And then you turn off your acetylene. Your flame will disappear because it's off. It's well noted, as this is designed for technology educators. These are flashback resistors. Older setups won't have them, but they are important because if a student is getting too close to their piece, they'll hear a pop and a hiss, and that means the flame has jumped into the torch head. And what the flashback resistors do is prevent the flame from following and running the hose to the tanks. So I have flashback resistors on the hose here. For some reason, if these failed, I also have flashback resistors on the tank. So you don't want to get that spark to the tank or else boom. And oxyacetylene has a bit of a bad rap with that. People think it's dangerous, but used correctly, it's quite safe and quiet and easy to work with, and a great tool to introduce to students because it's so quiet. So like I was saying, you turned off both valves on your torch here. So now it's time to go over. You're gonna turn off the acetylene. It doesn't quite matter which one you turn off quite from the tank first, but you make sure you turn off the oxygen first on your torch. So for sakes, let's go over to the oxygen. We're gonna turn it off. Turn off the acetylene. Come over back to your torch, because like I said, you need to bleed the hose. So we're gonna crack the acetylene open. You're gonna hear and it'll slowly quiet down. But you should be able to look at your regulator, and because it was set at 4 PSI, it's gonna go down all the way to 0, and your tank grip pressure will go too. So important to watch that, but now you know your hose has no more acetylene, probably has some residue, but it's not under pressure anymore. And you can do the same thing with your oxygen. So turn your acetylene off on your torch. You're gonna go over to the oxygen on your torch, crack that open. You'll hear a little hissing sound. And then the green hose will be flushed out, and watch the regulator. It'll go from 20 down to 0, and that's when you know to tighten it back up. Last step, most important step, because that's what wrecks acetylene or regulators, is you want to back this off, not too much like I did before, but you want to back it off because there's a diaphragm in there, and what the pin does is it pushes the diaphragm and allows oxygen, or in this case also acetylene, to go through. It bends the little diaphragm to allow the gas to go through. So by backing it off, you're taking the pressure off the diaphragm, so you're increasing the longevity of the diaphragm. So make sure you back these off, and once you do that, you're all set. You're safely shut off and you're ready to go, and you'll see in the next video or next portion that we use it. So jump to it. I won't take up any more of your time, so go back to see past chant. Alright. Okay, so we got our PP. Now that the head of the rose is all bent up and nice and cooled down for sure, it's time to bend up these tabs that make the kind of the bud of the rose, as well as give the leaves some life. So let's go ahead and do that. Okay, so all that is settling. I guess that was a bit lower than I thought, so that's not an issue. I just would have made the process a bit easier and a bit quicker too. If you're with grade 8s, it might be an idea to use a thinner gauge so you don't have to use heat at all. Or, like I said in the video, this project can be done with any gauge. So I'm going to go ahead and try to bend it by hand because it's not too thick. Anyway, I think I can bend it by hand. So, okay, let's jump to it. This brings us to the end of the presentation, but from here you could add thorns just with a little bit of tack weld with a MIG welder, or you could, if you had a powder coater like Spencer Jones did, shout out to Spencer Jones, he powder coated it a beautiful red and just gave it even more life. And if you have that available, definitely try that out, but I don't, so this is where the presentation ends, and I hope you liked it, hope you learned something, and I hope you can try it out. Alright, see you guys later.